This may sound like sacrilege here, but this is important. I use biometrics on my Google login, which is for my YouTube account on a Windows laptop. Intuitively, many of you who are privacy conscious will balk at using any kind of biometric-based login, particularly with Google. And you might also think I'm some sort of sellout and are disgusted with me. But I will tell you why I did it and why you should do it too in certain cases. Believe it or not, this is important to do for privacy. This actually solves a privacy problem I've been highlighting for a long time. I did an initial test with Biometric Login and will analyze the pluses and minuses of this. You'll find a lot of apps now showing a biometrics option in the login screens. However, not all biometric methods are safe, so we need to educate you on this so the subject matter is clear. Stay tuned for a deep investigation into the use of biometric logins. First of all, let me set up some general information here about the use of biometric logins. Bear with me here. Don't focus on asking about the dangers yet. I'll get to that. Here are the basics that we know in the summer of 2023. You will find that it doesn't work on all operating systems and older versions of operating systems. It is also not supported by all browsers. So in my test, I successfully used fingerprint biometrics in Windows using Windows Hello and then used that to sign into Google using Chrome. You will find, for example, that biometrics cannot be used on Linux currently, at least not on a standard Linux distro. I also cannot use it on an Android to Google device running Android 11, even when using Chrome. So this requires some coordination between the OS and the browser or the mobile app. What I'm using here is in the early stages. It is expected that newer versions of all the major OSs like macOS, Windows, Android, iOS will be supporting this in the fall. I don't know when other browsers will be supporting it other than Chrome. I also checked some bank apps and some now offer the biometric option in their mobile logins. But if the operating system does not support it yet, then you will not be able to turn it on. At least the bank apps that I checked did not have a biometric option on their browser login. I only found it on the mobile, so this must be something offered by the OS. Note also that there is currently no date for implementing this on Linux. I'm guessing this will be considerably delayed. And when it is fully implemented, it will be expected to be a replacement to passwords. However, it is a device-by-device thing, meaning biometrics are set up individually for each device. If you have a new device, you'll need to use one device that already has biometrics to allow another device to be added. In summary, don't expect this to be immediately operational. Consider my use of this as a beta test. Maybe it will take till 2024 sometime before this is completely implemented on most platforms. The first question that needs to be answered is if biometrics are safe. The use of biometrics in the specific case that I'm testing here is based on the FIDO passkey standard. So this is not something that is implemented independently by each platform and each operating system. I would not feel comfortable with logins based on some independent non-open source based technology. For example, Apple uses its own biometric API for use in Apple Pay or validating App Store transactions. In the case of the Apple ecosystem, it may be considered as acceptable to you, but that's because the Apple ecosystem already knows who you are, and I'm personally not happy about that. First, let's analyze the biometric technology that you will find on phones and laptops. The key feature in these devices is that biometrics are designed to be local, meaning there is no chance that the device is stealing your fingerprint data or face photo and sending it over to a third party or the HQ of the device OS. Why do I know this? Because of how the technology works. For example, let's talk about the fingerprint sensor. The fingerprint sensor does not take a picture of your fingerprint and then digitally process this in some way that can be recreated. That's not how that works. A fingerprint sensor uses a grid system, basically not that different from the touchpad on your laptop or the digitizer on your mobile phone screen. A predefined number of grid squares are embedded into the sensor. The sensor then calculates how much of your skin is actually touching the sensor in a particular grid square. This registers electrically as a capacitance value. Then the collection of capacitance values over all the grid squares will create some numeric value that is used as an identifier. The resolution of the grid squares is limited. It is not like a photograph. It would be pretty low res if it were. But since each square records a value of skin contact, it does not actually know which part of the skin is touching which part of the grid square. My point here from a basic technology statement is that it should be impossible to recreate a fingerprint using only the generated identifier, which is a single number. Also, the decision to validate the fingerprint, meaning a match in the numeric identifier, is made by the device OS. It is not done remotely. So the OS simply acknowledges to the platform that the biometric is validated. It does not send data related to the biometric. This is the same principle used in Face ID. The face recognition algorithm is different based on the capabilities of the device. Apple uses infrared, for example, to capture 3D data. Other devices use the standard camera, so the analysis is based on a 2D photo. Again, the analysis of the face is done locally on the device. A numeric identifier is generated and verified locally. Just like a fingerprint validation, it should be impossible to regenerate a face from the computed identifier, which I'm sure is also using a cyber technique called hashing. Now, each platform may choose to do biometrics independently. Zucking Zuckbook, for example, did work on using facial recognition to do Zuckbook logins. Fortunately, this did not come to pass. This is a lot different because here the actual photo from the camera would have to be sent to the platform and the photo processed in the cloud. Thus, this is an example of a very bad and very dangerous implementation of biometrics. Giving credit where credit is due, it was Apple that first started local device biometrics, where the secure information is kept in the firmware of the iOS device called the Secure Enclave. This now is consistent with how this technology is used in Androids as well. In summary, device-based biometrics is safe. The FIDO passkey standard, which is what is being implemented for general use, is based solely on device-based biometrics. So if the biometrics are using the FIDO standard, then you can be assured it is safe. The other misconception about biometrics is that if it is used as a password, then if it is stolen, it cannot be replaced safely since there is only one biometric and you cannot change your fingerprint or your face. This is not an issue with the FIDO standard. This is because the biometric is only used indirectly. The real security is provided by a random security key generated independently of the biometric. And this security key can always be regenerated. Let me explain how the FIDO standard works so we understand this. The FIDO standard, by the way, is built with an open source standard that is published and implemented by a collection of companies who are members of the FIDO Alliance. Many members of FIDO are competing organizations, so this means the standard will not be driven by the market control of one particular company like Apple, Google, Microsoft, or Meta. Now, how does the FIDO biometric technology actually replace passwords? It does this by generating a random key pair, a public and private key, using the well-known RSA standard. And then the device reveals the public key to the platforms needing validation, but without ever revealing the private key, which is only on one device and only works for one platform. In other words, if the biometric is validated, the public key is passed for that platform, not the biometric. The passing of the public key allows an encrypted conversation, so further validation can continue. This means that there is no actual identifier sent with the public key that identifies the user. It is the platform that sends an encrypted code, and the user device just has to return a response which assures both parties have their private keys. During the setup of the biometric login or FIDO passkey, of course, you have to be validated to be the same user using a password at first. But in theory, if this is a new account, then a password wouldn't even be necessary. And this is the goal of the FIDO standard, and that is to eliminate the friction of passwords which everyone has to memorize, and every password needs to be different for each platform and be subjected to completely different rules of construction. We all know passwords are a pain. However, the most serious cybersecurity threat is, of course, the stealing of passwords. If your password is collected from the many hacks of major platforms, then your security is compromised and your accounts can be hacked. If you use a biometric passkey, then that threat is eliminated. The question we need to answer, though, is if this solution comes at the cost of privacy. And there are good news and bad news here. Let's first start with the bad news. And this bad news only impacts a certain portion of the population. The main bad news is that the biometric login, so far, is not protected by the Fourth Amendment in the US. This means a law enforcement official can force a biometric login on you passively by pointing the phone at your face or touching your fingers to the fingerprint sensors without your permission or a warrant. In contrast, if your phone requires a code to allow access, you are not obligated to reveal this code or pattern. This is a particularly sensitive issue when traveling internationally, as the laws in each country differs. So it behooves you to consider how much data you keep on your phone. Now, let's talk about the good news. And the good news is fortunately very good. Currently, in order to validate your login, your platform ties you to a specific identity, typically an email and a phone number. We are all familiar with the dreaded two-factor authentication requirement, or 2FA, on practically all platforms. This is particularly dangerous because certain sites collect contact list info from many users and thus have a directory of emails and phone numbers available to them already. Because of this, these large platforms have your identity figured out. In other words, 2FA is tied to the danger of identity collection. Thus, what you do on the platform is tied to you specifically. Any attempts at pseudo-anonymity will not work because they have superpower capabilities. They always know who you know, and your identity is crowdsourced. This is a big threat to freedom because you are not able to speak freely if someone is collecting your words and thoughts and then classifying you in some way for some third party to judge. So the real advantage of FIDO passkeys or biometric login will come later. It will come when we actually eliminate passwords and eliminate 2FA phone numbers. The substitute to 2FA will come instead in the form of multiple devices with biometric logins, for example. Now I don't trust this capability fully yet, so I still want a backup using email and passwords. Though maybe phone numbers can be eliminated immediately. But as we see this stabilize in the near future, then this will be the solution I'm looking for to eliminate the use of phone numbers in apps and websites. In the meantime, I have to admit it is a pleasure to be logging onto Google without having to type in a password. I highly recommend switching to this wherever the platforms allow it. Just make sure it is using the FIDO standard. So keep an eye on this new tech. It's developing rapidly and you may not understand what is being presented to you, but it will be good. Folks, my company creates products that are intended to protect our privacy. We provide phones that have no centralized control and are invisible to big tech. Our most popular device is the Brax 2 phone running Brax OS. We also have Pixel phones that have Google removed. These are called the Google phones. We have a VPN service, Bytes VPN, which is a stealth VPN in that it doesn't scream that you're on a VPN. We do not put thousands of you on a single server. We have Brax Mail, which eliminates the metadata from your emails. This means no IP addresses and traces on your email that show where it came from. All these products are on the store on my app, Brax Me. Come visit us there. The link is in the description. Thank you for watching and see you again soon.